It can watch a video of something like a person and then learn just by looking at that video and do that task.
This is precisely Elon Musk's vision, opening up the prospect of robots learning and working like humans. To realize this, Optimus Gen 4 has been completely redesigned. The head is smarter, the chest panels are more compact, and the overall appearance is more user-friendly. Notably, the Gen 4 head is equipped with 8 cameras and multi-directional sensors, allowing 360-degree observation and improving accuracy in interaction. Why is the new design important for the next generation of Optimus? Before we begin, please help us reach 20,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How did Tesla redesign the head of Optimus Gen 4 to improve interaction? When you think of humanoid robots, which part do you consider the most important? Many people would immediately say the hands, since that's what allows a robot to grab and perform tasks. But if you look closer, you'll realize the head is actually where the real connection between humans and robots begins. And with Optimus Gen 4, Tesla has made a striking change in this very area. Previously, Optimus's head had a rather rigid design. It looked mechanical, almost like a camera awkwardly attached to a body. Modern, yes, but also cold, lacking a sense of warmth or familiarity. Think about it. If a robot walked into a room with a completely expressionless face, would you feel comfortable? Probably not. That's why, in Genesis 4, Tesla reworked the entire head, from its shape and sensors to how it expresses states. The most noticeable difference is its sleeker, more harmonious shape. The lines are softened, no longer as sharp and mechanical as before. This may seem like a small tweak, but it makes Optimus appear far friendlier, more like a teammate than a machine. Elon Musk once said that robots should make humans want to be around them, not feel fear or distance. That philosophy is exactly why Tesla invested heavily in reshaping the face of Optimus Gen 4. But the head isn't just about looking better. Tesla has packed it with an advanced sensor suite. Imagine Optimus now having multiple eyes, a wide-angle camera for full view, a telephoto camera for detail, infrared sensors for the dark, and directional microphones to catch voices around it. This means Optimus doesn't just see, it actually understands its environment, much like how we use our eyes and ears to read situations. And what's the benefit? Picture yourself sipping coffee. Optimus notices your cup is nearly empty, and without being asked, it understands you're about to need a refill. No commands, no instructions. It simply acts. Wouldn't you want a helper like that at home? Another intriguing upgrade is how the head can now express subtle emotions. Tesla has added a front-facing LED strip that lights up differently depending on states, when listening, when processing, or when completing a task. On top of that, head movements are more natural. It can nod to agree or tilt slightly when listening. Sound familiar? These are the same small gestures we use in daily communication, and when a robot does them, it feels like it's genuinely listening. Compared to rivals like Figure 02 or Agility Robotics Digit, the difference is clear. Figure 2's head looks futuristic and sleek but feels distant. Digit barely has a head at all, no expressions, just pure mechanics. Tesla chose a different path, design that's both attractive and approachable, while cramming in cutting-edge tech. In other words, the head of Optimus Gen 4 is both its brand face and its neural center. In practice, this change also boosts safety when working alongside humans. With 360-degree vision, Optimus can avoid collisions, recognize small gestures, and react instantly. For example, if you point toward a chair, it understands you want it pulled out, without needing a long verbal command. That's the difference Tesla is aiming for. Robots that don't just follow orders, but respond with human-like intuition. Elon Musk once said, Optimus is not just a labor tool, but a companion. To achieve that, a robot can't only be powerful in its arms and legs, it needs to have a soul in its head. And Genesis 4 is on the right track, turning a machine into a technological being that feels close enough to live and work with us. Overall, the head redesign of Optimus Gen 4 is a makeover that matters. It makes the robot look better, act smarter, and, most importantly, become easier for people to accept in daily life. Because at the end of the day, what makes us open our hearts to a robot isn't how fast it runs or how much weight it lifts, but whether we feel we can communicate with it and trust it. Once again, please help us reach 20,000 subscribers. This is important for us to stay motivated. Thank you. Why was the chest panel changed in the new design? If you think a robot's chest is just there to cover up the machinery inside, you're in for a surprise. With Optimus Gen 4, Tesla doesn't treat the chest plate as just another piece of plastic or metal. It has turned it into a crucial part of both design and functionality. And this change is big enough to make you look at Optimus in a completely different way. Think back to Optimus Gen 2 or Gen 3. The chest back then was thick and bulky, almost like armor. Sure, it was solid, but it also made the robot feel distant and heavy. Elon Musk has often emphasized that humanoid robots should appear friendly and approachable, not like warriors straight out of a sci-fi movie. That's why in Genesis 4 the chest has been significantly refined, slimmer, smoother, and smarter at the same time. The first thing you'll notice is the elegance of its form. The Gen 4 chest plate now has a seamless design with soft, rounded edges that give off a lighter, more approachable look. Don't you think that when something looks better, we're more likely to accept it? It's just like smartphones. No one wants to carry around a bulky, blocky phone, right? Robots are no different. They need an appearance that's easy on the eyes. But Tesla didn't stop at aesthetics. The new chest plate is made of ultralight materials, likely an aluminum alloy combined with carbon fiber. This reduces the robot's overall weight, meaning Optimus can conserve more battery power and move more fluidly. A robot that's a few kilos lighter can walk longer, balance better, and most importantly, be safer around humans if it ever bumps into them. Wouldn't you want a robot that's safer to have in your living room? Another interesting detail. Tesla has turned the chest into a platform for new technology. Reports suggest that the Gen 4 chest may integrate a small display or smart indicator lights, allowing the robot to show its status, charging, idle, or processing tasks. It might even display a simple greeting like hello to feel more welcoming. Suddenly, the chest isn't just armor anymore, but more like a mini control panel built right into the robot's body. Look closer and you'll notice that the chest redesign also improves cooling. Inside Optimus, many critical modules like batteries and processors are housed in the upper torso. With the new design, venting and airflow have been cleverly integrated beneath the chest plate, balancing aesthetics while keeping the robot running longer without overheating. Who would have thought a robot chest could double as a mini air conditioning system? Strange as it sounds, it makes perfect sense. And how does this compare to competitors? Figure 02 still uses a fairly minimalist chest design, sleek but lacking multifunctionality. Digit, from Agility Robotics, basically ignores aesthetics altogether, focusing purely on industrial mechanics. Tesla has chosen a different path. A chest that looks good, houses useful tech, and strikes the balance between performance and user experience. This has very practical implications. At home, Optimus could use its chest display to show your daily schedule, remind you to take medication, or notify you when a meal is ready. In a factory, the chest could display statuses like transporting or needs maintenance, making it easier for workers to keep track of dozens of robots at once. See how a simple change to the chest can unlock an entire range of new use cases? Elon Musk has repeatedly emphasized Tesla's vision of making Optimus a mainstream product, present in homes, offices, and factories alike. To achieve that, a robot must not only look approachable, but also communicate clearly. And the chest is the perfect spot for delivering quick, visible information. Instead of checking an app, you can simply glance at Optimus's chest to know what it's doing. A small design tweak, but one that offers huge convenience. In short, the redesigned chest plate on Optimus Gen 4 isn't just about making the robot look better. It makes it lighter, smarter, and more user-friendly. It transforms the outer shell into a communication tool, an essential part of the user experience. And it's this blend of technology, aesthetics, and functionality that brings Optimus Gen 4 closer to Tesla's ultimate goal, becoming a true partner in human life. So what do you think? Would you rather stand in front of a robot whose chest is just a hard shell, or one with a smart control panel built right into it, both sleek and useful? The answer seems pretty clear. What are the key exterior adjustments that make Gen 4 look more human-like? If you think a robot's chest is simply there to cover up the machinery inside, you're in for a surprise. With Optimus Gen 4, Tesla doesn't see the chest plate as just a piece of plastic or metal, but turns it into a crucial part of both design and functionality. And this change is enough to make you look at Optimus in a completely different way. Think back to Optimus Gen 2 or Gen 3. The chest back then was thick, a bit clunky, almost like armor. It was solid, sure, but it also felt heavy and distant. Meanwhile, Elon Musk has emphasized that humanoid robots need to look friendly and approachable, not like warriors walking out of a sci-fi movie. That's why Generation 4 received a major redesign. A chest plate that's slimmer, sleeker, and smarter. The first thing you'll notice is the refinement in shape. The Gen 4 chest has a seamless design with softly rounded edges that give it a lighter visual impression. Equally transformative are the refinements Tesla made to Optimus Gen 4's arms and hands. If earlier versions looked somewhat mechanical and stiff, the new design leans heavily toward natural human proportions. The arms now feature smoother contours, less exposed machinery, and joints that mimic the range and fluidity of a person's shoulders and elbows. This change does more than improve appearance. It directly impacts functionality. With arms shaped closer to our own, Optimus can move through everyday spaces without looking awkward or threatening, making its presence feel more natural in homes, labs, or factories. The hands represent another leap forward. Gen 4 introduces slimmer, more defined fingers with enhanced articulation, giving the robot a distinctly human-like dexterity. Where Gen 2 and Gen 3 hands resembled tools, Gen 4's design suggests something closer to a true replica of the human hand. This isn't just cosmetic. It makes tasks like handling fragile objects, pouring a drink, or typing on a keyboard far more believable and practical. A humanoid robot must blend seamlessly into human-designed environments, and Tesla clearly understands that our world is built for hands like ours. Moving downward, the legs and feet of Gen 4 also showcase a more refined silhouette. The bulky, almost mechanical look of earlier prototypes has given way to leaner, better-proportioned limbs. The thighs and calves are shaped in a way that mirrors human musculature, while the knees bend with more grace. The feet, often overlooked in humanoid robots, have been redesigned to provide a more stable base, with proportions that resemble human shoes rather than clunky industrial supports. This not only enhances walking efficiency, but also reduces the uncanny sense of robot legs moving stiffly across a room. Tesla has even paid attention to posture. Where Gen 3 occasionally looked hunched or overly rigid, Gen 4 maintains a balanced, upright stance that feels strikingly human. The alignment between shoulders, hips, and feet gives the impression of a figure at rest, ready to move, but not mechanical in its stillness. This posture is subtle, yet it is one of the most convincing aspects of the redesign, making the robot appear less like a machine imitating humans and more like a being that naturally shares our body language. Taken together, these refinements to the arms, hands, legs, and posture complete the Gen 4 transformation. Tesla has moved beyond creating a robot that merely performs tasks to designing one that looks at home in our world. By bringing its form closer to ours, Optimus Gen 4 doesn't just resemble a humanoid, it begins to feel like one. Tesla Optimus Gen 4 is becoming the center of attention after Elon Musk revealed a series of major upgrades in both design and technology. Not only does it feature a more human-like appearance, but Gen 4 is also positioned as the version that will drive large-scale commercialization, marking the transition of humanoid robots from the testing phase to mass production. The big question is, how many units of Gen 4 will Tesla produce, and when will it officially launch? Following Tesla's usual strategy, production will not begin on a massive scale right away, but instead start at a smaller volume to ensure quality control and stabilize the supply chain. For Optimus, Elon Musk has stated that the long-term goal could reach millions of robots per year, but Gen 4 will likely begin at a more modest level. Experts predict that in the initial phase, Tesla may produce around 10,000 to 20,000 units annually, concentrated in a single factory in the US, before expanding to other gigafactories. What stands out is that Tesla is applying lessons from its electric vehicle production lines to accelerate robot manufacturing. The use of gigapress, automation systems, and 4,680 battery technology allows Tesla to significantly shorten assembly time. Whereas the Model Y took nearly 3 years to reach stable production, Optimus Gen 4 could need only about 18 to 24 months before entering a phase of rapid growth. This means that starting from 2026, we may see Optimus Gen 4 deployed widely in factories, laboratories, and even households. As for its official launch, Elon Musk has repeatedly hinted that Gen 4 will be unveiled in 2025, possibly at Tesla AI Day or a dedicated event to underscore Optimus's importance for the future. This will not just be a showcase of technology, but also a declaration that Tesla is ready to commercialize humanoid robots. In summary, with an initial production plan of several tens of thousands of units per year and a clear roadmap for scaling up, Optimus Gen 4 is poised to become Tesla's next flagship product. If Elon Musk's prediction holds true, the future value of Tesla could come primarily from Optimus, and Genesis 4 represents the turning point that opens the door to a global era of robotics. In a new video shared on X,
"Hey Optimus, do you know where I can get a Coke?"
Sorry, I don't have real-time info, but I can take you to the kitchen if you want to check for a Coke there.
Tesla showcased Optimus Gen 4's ability to answer questions thanks to AI Grok, surprising viewers. Elon Musk personally introduced the new version to Salesforce CEO Mark Benioff, providing a first look at the upcoming technology. So, what makes Optimus Gen 4 special compared to previous generations? Before we begin, Please help us reach 20,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How does the Gen 4 joint design make the robot more flexible and durable? In the transition from the early white prototype of Optimus to the new Optimus Gen 4, the real breakthrough does not only lie in the overall appearance, but is deeply rooted in the joints, the core elements that determine aesthetics, durability, and performance. If the old version was designed by Tesla as an open skeleton to serve research and testing, then Gen 4 has truly stepped into the stage of commercialization, where every joint is not only better protected, but also delivers a more natural, approachable, and premium feel. The shoulder and arm joints stand out as one of the most significant improvements. In the white prototype, all bearings, shafts, and servo motors were exposed, making them vulnerable to dust and limiting their lifespan to just about 5,000 to 7,000 hours of continuous operation before requiring maintenance. In Genesis 4, Tesla covered the shoulders with lightweight composite shells capable of withstanding impact forces of 15 to 20 megapascals. This made the robot more durable while reducing its overall weight to below 55 kilograms. Thanks to this protection, arm movements have been optimized, allowing up to 200,000 flexion extension cycles without component replacement, an essential upgrade given that Optimus is expected to work continuously in factory environments. The elbow and wrist joints have also undergone a thorough redesign. Previously, exposed cables and mini pistons were prone to collecting metallic dust and oil, which could reduce servo efficiency by up to 10% after only a few weeks of 8-hour daily shifts. Gen 4 solves this by fully enclosing the joints while also shrinking the wrist diameter to just about 70 millimeters, down from over 100 millimeters in the old version. This not only makes the hands more agile, but also significantly increases the precision of gripping motions. Optimus can now perform tasks with a positional error margin under 2 millimeters, on par with specialized industrial robots from ABB and KUKA. The hip and waist joints, considered the robot's center of force, have also been reinforced. The earlier prototype exposed bolts and support rods that bore loads unevenly, resulting in only about 80% stability on smooth floors. With Gen 4's rounded shells and rebalanced weight distribution, stability now exceeds 95%, enabling the robot to walk on surfaces sloped up to 10 degrees without falling. This is a major leap forward, since in industrial settings, a robot falling over can cause damages worth tens of thousands of dollars due to equipment breakage or production downtime. The knee joints in Generation 4 have been upgraded to drastically improve durability. The old design, with exposed pistons, supported only about 100,000 bending cycles. In contrast, the new sealed design has been tested internally to endure over 300,000 bends. This translates to 3 to 5 years of average factory operation before knee replacement is needed, cutting maintenance costs by at least 40% compared to the prototype. Such an advantage becomes decisive if Tesla plans to deploy thousands of Optimus units on automated production lines. The ankle and foot joints highlight Tesla's clear commercial intent. The earlier model used flat feet with a contact area of just about 120 square centimeters, which limited balance during fast walking or turning. Gen 4 adopts a sneaker-style foot with an expanded contact area of nearly 200 square centimeters, paired with industrial rubber soles boasting a friction coefficient of 0.8, almost 30% higher than before. As a result, Optimus can now walk at 5 kilometers per hour while maintaining balance, a speed nearly equal to the average human walking pace of 5.4 kilometers per hour. This brings the robot far closer to real-world usability, rather than being confined to laboratory conditions. Altogether, these improvements carry critical implications. Aesthetically, Optimus Gen 4 presents a refined, high-tech look more akin to a premium consumer device than a rough research prototype. In terms of durability, joint lifespan has increased 2 to 3-fold, from around 5,000 operational hours to as much as 15,000 under industrial conditions. Functionally, the robot now achieves motion precision under 2 millimeters, making it suitable not just for factories, but also for offices, healthcare, and household tasks. In terms of reliability, the sealed design reduces breakdown risk and lowers maintenance costs by 30 to 40%, a decisive factor if Tesla aims to mass-produce millions of Optimus units in the coming decade. These figures show that Tesla's focus on joint redesign is not merely about aesthetics, but directly enhances reliability, efficiency, and commercial viability for Optimus Gen 4. This is the evolution that transforms the robot from a technical prototype into a real-world product deployable on a global scale, while at the same time reinforcing Elon Musk's vision of a future where humanoid robots serve as a foundational element in both the economy and daily life. Once again, please help us reach 20,000 subscribers. This is important for us to stay motivated. Thank you. How does the new Gen 4 joint design enhance the robot's performance and lifespan? One of the most significant changes between the earlier white prototype of Optimus and Optimus Gen 4 lies in the materials and overall structural design. The older version mainly used exposed metal framing, giving the robot a rigid appearance and making it more prone to damage upon impact. In addition, the thick and heavy metal plates considerably increased the overall weight. By contrast, Optimus Gen 4 adopts an advanced composite shell or an aluminum-magnesium alloy, which Tesla has extensively researched in the EV sector to achieve an optimal strength-to-weight ratio. This material is 15 to 20% lighter than conventional steel while being 1.5 times stronger, allowing the robot's weight to drop from around 65 kilograms to under 55 kilograms. This nearly 10-kilogram reduction not only improves energy efficiency, but also makes Optimus more agile, reducing battery consumption and enabling it to perform more tasks without frequent recharging. The change in materials also brings notable improvements in structural durability and load resistance. In the older white prototype, joints in the frame were easily deformed when the robot experienced impacts or unexpected loads, limiting its application in factory environments where collisions are common. Gen 4, with its composite design combined with a scratch-resistant coating, can withstand forces 1.5 to 2 times greater than before. This significantly extends structural lifespan and minimizes the need for part replacement, thereby reducing both mass production and maintenance costs for customers. Tesla is not just optimizing appearance, but is pursuing a philosophy of longevity. The robot must be able to operate continuously for many years in harsh conditions without requiring major replacements. Another crucial factor is the center of gravity and dynamic balance. The earlier white version often struggled with stability when moving quickly or making sharp turns due to suboptimal weight distribution. Its center of gravity was positioned slightly too high, while the legs were not agile enough to compensate in time. This limited its use on uneven terrain or inclined surfaces. Gen 4 addresses this problem by redesigning the internal layout, placing heavy battery packs and processors closer to the hips and legs, thereby lowering the center of gravity. At the same time, its new balance control system, developed on the same AI platform Tesla uses for self-driving cars, can predict and adjust forces on each leg within milliseconds. As a result, the robot can now walk on surfaces inclined at 10 to 15 degrees without falling, something nearly impossible for the older version. This breakthrough greatly expands Optimus's potential to work in multi-level warehouses, construction sites, or even domestic environments with uneven ground. Equally important is the aspect of appearance and social acceptance, a decisive factor in widespread public adoption. The white prototype, with its exposed metal skeleton, often gave the impression of a machine skeleton, which could feel alien or even intimidating to people interacting with it. By contrast, Genesis 4 features rounded contours, a more human-like body shape and feet designed to resemble shoes. These improvements go beyond aesthetics and carry strategic significance. A robot that looks approachable and friendly is far more likely to be welcomed into homes, offices, or hospitals. Studies in human-robot interaction have shown that a human-like appearance and approachable design can increase social acceptance by up to 40% compared to rigid mechanical designs. Tesla appears to have grasped this well, shaping Gen 4 not merely as a labor machine but as an intelligent assistant. Beyond aesthetics, maintenance and durability have also improved dramatically. In the older white version, joints and mechanical parts were often exposed, making them vulnerable to dust and moisture, which accelerated wear. The average lifespan of these components was only about 2 to 3 years under continuous use, resulting in high maintenance costs. Gen 4 overcomes this with sealed joints, anti-wear coatings, and high-strength materials, extending joint lifespan by 2 to 3 times, equivalent to 5 to 7 years of reliable operation. Tesla also claims that average maintenance costs could be reduced by 30 to 40% compared to the previous generation. When scaled to thousands of robots deployed in factories, these savings become highly significant and provide a clear competitive advantage over rivals such as Figure 02 and Agility Robotics. Energy efficiency and battery performance are among the most critical highlights of Optimus Gen 4. The earlier white prototype, due to its heavy design and non-optimized systems, consumed high amounts of energy, operating only about 3 to 4 hours before requiring a recharge. This fell short of the real-world demands of factory work, where shifts last a minimum of 6 to 8 hours. Gen 4, with its reduced overall weight and improved dynamics, has extended operational time to 6 to 8 hours, using the same battery capacity. This means the robot can now work an entire shift without interruptions for charging, maximizing labor efficiency and reducing the total number of robots needed for rotation. A single Gen 4 unit can effectively perform the work of 1.5 older robots, allowing Tesla to cut production costs and ease the strain on charging infrastructure in industrial settings. Not only has runtime improved, but Gen 4's battery and power management system is also equipped with artificial intelligence to allocate energy more intelligently. For instance, when the robot is idle, the system automatically reduces power to unnecessary motors, maintaining only essential supply to sensors and processors. This mechanism further cuts average consumption by 10 to 15% compared to the previous model. Additionally, Tesla can leverage its 4680 battery technology, or even move toward solid-state batteries in the future to increase energy density. This long-term strategy ensures that Optimus will be capable of sustaining full-day operations in production environments without disrupting workflow. Bringing all these elements together, the differences in Gen 4 extend far beyond technical refinements. They reflect a clear strategic direction. Lightweight yet durable materials, optimized structural layout, lowered center of gravity, approachable design, extended durability, and enhanced battery performance all combine to create a machine far more practical than its predecessor. Tesla has demonstrated that it's not merely building a prototype for demonstration, but is moving toward a truly commercial product. The fusion of technical excellence and social adaptability positions Optimus Gen 4 as a new benchmark in humanoid robotics, paving the way for widespread deployment in both industrial and consumer sectors. In the early prototype, Optimus mainly relied on cameras and a few basic sensors, similar to what Tesla initially tested on its self-driving cars. This setup allowed the robot to recognize objects at a basic level, but its accuracy in distinguishing small items, human gestures, or complex environments was still limited. For example, it could tell the difference between a large box and a wall, but struggled with thin, fragile objects, or when people communicated through hand signals. Gen 4 represents a major leap forward, thanks to the integration of high-resolution cameras, force sensors in both hands and feet, along with short-range radar. These upgrades enable Optimus to achieve perception capabilities on par with, or even beyond, advanced industrial robots. Estimates suggest its object recognition and positioning accuracy has risen to around 98%, compared to below 90% in the earlier prototype. More importantly, Optimus Gen 4 can detect and respond to human movements within 50 to 100 milliseconds, approaching the reflex speed of a real person. The significance of this upgrade goes far beyond improved collision avoidance or more precise gripping. It paves the way for Optimus to operate safely in shared spaces with humans without posing risks. This is a crucial factor for Tesla to commercialize Optimus in fields such as healthcare, customer service, or home assistance, where safety and user-friendliness are absolute priorities. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.